All right, in this lesson here, we're going to be talking about weighted averages. And I want to make sure that we understand the need or the basic idea of what a weighted average is. And I'm going to do this by talking about something that's hopefully fairly easy to understand. You might be too young to really appreciate it, but let's talk about mixing an alcoholic beverage. So suppose I've got a cup here. It's a very crude drawing of a cup, but there's a cup. And suppose I'm going to mix half of it with a 90 proof alcohol and the other half of it with some sort of mixer, which means it's not alcoholic at all. And when I mix them half and half and want to know, hey, what's the concentration or the proof of this drink, we could just average them. We could add 0 and 90 together and then divide by 2, and it would be 45 once we've mixed it. And that's our typical idea of average. Our typical idea is to add things together and divide by how many there are. But that's typically when they're weighted equally, that the amount is the same. So now we want to look and say, well, what if I dropped this down a bit and I only put in a little bit of alcohol and all the rest of it was non-alcoholic? Is it still going to be 45 proof? No, it's going to be much less because it's no longer 50-50. Because before what I did is I actually was saying half of it was 0 and half of it was 90. And when I add those together, I got 45. Now what I'm doing is let's go ahead and say this is, we'll say 10%, and this is 90% of it. Now we're saying 90% of it is at 0, and 10% of it is at 90 proof. And now if we add those values together, that will get us the proof. That's the basic idea of a weighted average, is we want to say based on how much of it is each, we're going to figure out an average based on that. So that, for instance, if we look at this table over here, we have a weight of 0.1 for our zeros, a weight of 0.15 for the ones, a weight of 0.2 for the twos, and we can kind of think about this like saying 10% of this are zeros, 15% of them are ones, 20% are twos, and 55% of these are going to be three. So we can't ignore this and simply say, I can add these up and divide by 4. That if we add 0, 1, 2, and 3 together and divide by 4, we're going to get 6/4 or 3 halves or 1.5. So 1.5 isn't going to necessarily be our average here, because if we look at what's going on, 55% of these are 3. And then 20%, so just under a quarter, so actually that would be more like this, are 2s. So if we look at that, 3/4 of our data here are 2s and 3s. And then we've got a few 1s and even less zeros. So if we look at what this average value is going to be here, it's going to be more than 1.5, because we can see that 0 and 1 only account for a quarter of our data here. So let's talk about how we calculate one of these weighted averages. So one way to do this by hand is to multiply the value and the weight together and then divide by the total weight, where in this case all of our weights add up to 1, and so that's all right. So in this case here, 0 times anything is 0, 1 times 0.15 is 0.15, 2 times 0.2 is 0.4, and then 3 times 0.55 is going to get us 1.65. And if we add together all of those values, I'm using the calculator on the side here, if we add together all of those, we'd get 2.2. Now we would normally then divide by the weight, the total of all the weights, but the total of all our weights here are 1. And so in this case here, we get 2.2 as our weighted average. So that's how we can do this by hand. And so we can see it's not simply the regular average of 1.5 because of the weighting. But I also want to show you that you can use your calculator to do a weighted average like this and save yourself a lot of work, especially as we get into bigger data sets. We can do this by first of all inputting the values in by going to data. So if we click on data in our graphing calculator, in the first column we can go ahead and put in our 0, 1, 2, and 3. And then we can arrow over to our second column and we can put in the weights of 0.1, 0.15, 0.2, and 0.55. So now we're going to go to the stat menu, which is second and then data. Now we only have one variable here, which is the x. So we're going to go to one variable statistics, but we're going to come down to what's called the frequency. And you're going to arrow over to your list 2 so that our second column is our frequency or what the weight was for each of these, and make sure you're highlighted on L2 and then go down to calc. And the X bar here is going to be the mean or the average. And so we're getting 2.2, which is what we calculated by hand as well. Now, a really good application of a weighted average is your GPA, your grade point average. That when we look at the grades that you earn in a class, it's weighted based on the number of credits that you take. So in this example, we have Ahmed here, who his grades are given, and we're going to calculate his GPA. And so we could do this by hand, by multiplying together the weight in this case is the credits, the weight and the grade get multiplied together, where we're going to get 2.8 here, we're going to get 5.1 here, and then we're going to get 5 times 2.5 is 12.5. And so as we're looking at this and getting a ballpark idea, the 2.5 is very heavily weighted. So that's actually bringing his grade point up. Not that he got very good grades here, but it's bringing it up. And so if we add these together, 8 plus 1 is 9. So we get 4, carry the 1. 3, 5 is 8, plus 2 is 10. So we got 20.4 when we add them. But now we got to realize that 20.4 is the grade points that he has earned. To get the grade point average, we need to divide by the number of credits that he took. He took 10 credits total, so we need to divide by 10, which is going to get us a 2.04 grade point average. Now, if you remember, we said that we can do this in the calculator for weighted averages as well. So let's bring the calculator up, and if we click on the data button, then we can start typing in the first column of 1.4, 1.7, and 2.5. Then we can arrow over to the second column where we have 2, 3, and 5. And remember that what we want to do is go to the one variable statistics, and we want to make sure that L1 is where our data is at, that was the grades, and that L2 is the frequency or the weights. And that is how we had it set up. So if we go to calculate, the X bar is 2.04, which is exactly what we got by hand.